Okay, I've got some sound, and we're ready to do part two of the March 7th class. And as I mentioned, we were finishing out chapter 12 in the Patrick text, and now we're going to work on chapter 13, and we're going to deal with inner joins. I can't emphasize enough to you, as I did the other day, you need to really have your textbook with you when you come to class, or if you view the live stream, or if you choose to view it on demand. We're going to be over here in chapter 13, and we're going to talk about inner joins. So, first thing we're going to do, of course, you'll want to do is to go ahead and make sure that you have the Patrick materials. I'll just diminish this down for a second. And this will be my Patrick materials. Here you are. I downloaded the zip top to my desktop. So here's the Access SQL code. All right, and there's the code for chapter 13. I'm going to copy it and throw it out here. Okay. Paste that here. I have it out here somewhere now. And there we go. There's the code for chapter 13. Now, also, I'm going to back up. And I'm going to go ahead and get the SQL file. Because that's my data warehouse. Okay. And I'm going to call this SQL file. I'm going to rename it chapter 13. Okay. Now, I've got my book beside me here, and the first thing I'm doing is I'm looking over here on page 474. And you may have to turn your volume up a little bit. I'm afraid I'm coming down with sore throat or something's going on. I'm not sure, but I don't have my voice as I usually do. So we'll go forward from there. Over on what would be page 474, you're going to see the text, and as it talks about the introduction to joins, inner joins of two tables, variations of the join conditions, applications of them. And as the author points out there in 475, we really have three types of joins. One is what we call the inner join, the second is what we call the outer join, and then we have what I would call right and left outer joins, and then the inner join. Now, I'm going to come over here for just a second and take a look at, before I go any further, I do want to encourage you to take a look at these websites. These are databases and links to some people that work in humanitarian aid, and here's the Baptist General Disaster Relief Portal. Here's an interesting article from the Center for Data Innovation here, Geosystems, how they can be used. And I can't emphasize that enough. There are some fantastic ways that you can go to work and find some real meaning in your work, particularly working with disaster agencies if you so choose to do it. Okay. Here's even one that's crowdsourced, the Disaster Response Wiki. Now, as usual, we're working way ahead, because as you come to the end of the course, I'm going to have some projects for you, and you'll also have your final exams, so we're moving pretty rapidly. I'm going to look up here for just a moment in the course resources, and I'm going to see if I had a chapter 13 that you could take a look at. If not, there's 11. There's a Lynch's database 13. So you can use it if you want to turn in your credit for Lynch's database 13, okay? So you do have that. And of course, I have indicated where you need to upload 13 for your work. And we'll go back over here to the modules. I'll close this off. And again, we're working way ahead on these. Now, I'm going to diminish this browser, and I'm going to get started on talking about inner joins. Okay. Now, I believe, if I'm not mistaken, I also have some links to resources for you about inner joins. So let me take a look here. Back up with the welcome module. Okay. And let's see. Thought for sure I had some resources that will help put it into perspective for you. Here you are. Exactly. Now, this is a very simple, but I think effective way to look at these. These are the Venn diagrams that fit for inner joins, a left outer join, and a right inner join. When we do an inner join, we say, I only want where these two tables, for example, match up. And you remember we've talked about primary keys and then what we would call a foreign key. Primary key is a field or column or dimension that is a unique identifier for a record. And typically it's the primary key. Then you can also take that primary key, for example, say employee ID, and put it into another table. And at that point, then it becomes what we call a foreign key. And because you have the ability to link the two of them up, you can link up tables. And so joins are powerful, powerful tools for us to use to leverage large bits of data that are in tables. The left outer join simply says, I want everything in this, what I would call the parent table, over here in the blue, and wherever they match. Finally, there's what we call the right outer join. And that's where we extract data where the two tables match and everything else from what we would call the child table. That's really all it's about. Now, you'll notice again, and I've mentioned quite a bit about the analytical cube. As you can see, we've worked on row functions. We've worked on column functions. Now, we really amplify the ability to really get a fuller and richer picture of transactions or of our customers' characteristics or events out of the environment, any of those kinds of things that we catalog and we put into our data warehouse. And we can run queries then that slice and dice by really, and here we can start to really build that cube as we take two tables 3 tables, 4 tables, and link them all together. Now, I've got a link here on left outer joins, on right outer joins, and then inner joins. Okay. Now, I really think if you want to get the total benefit of this lecture and this class session or screencast, as well as what we're doing from here on out, it's in your best interest to go over here and take a look at this slideshow on data mining. You're going to hear a lot of people talk about that and what does it mean. And for all intents and purposes, then you'll understand the term. This is a great resource, data mining from A to Z, how to reveal, and it walks you through a procedure, a process, a series of steps. Here's an interesting bit of information or resource about the growth of what we call unstructured data, and helps you understand all that. Here's a link to SAS Web Analytics. You can see with these resources. I think this is a film, if I'm not mistaken, on a day in the life. Okay, it's a nice resource. I think it's worth looking at because it shows you some very practical ways that when we harness big data, particularly unstructured data, that we can begin to really provide some services for people. I think if you want something with meaning, something that's really inspirational, I would encourage you to come over here and look at the self-driving car. It's a fantastic resource here, and I believe this is a YouTube video where there's a gentleman who's legally blinded because he has a self-driving car. He can go to the store, run his errands, live his life. It wouldn't be possible to have that type of vehicle without a database. So let's continue on and take a look and run some code here. Again, this is going to be chapter 13, and when we're finished, you'll want to upload it. Now, I'm going to open up my warehouse. All right. Now over there on page 476, the authors really show you in a very nice diagram how we take all this data and we turn it into information. Remember, information is data that's actionable. I can make a decision. I can form an opinion. And as you see here, they walk us through the process of where they pull the first step, cull the data from these 4 tables. So we end up with the ABCD table. We have a composite picture. And then we do our second step, and notice we extract our result table. This is a revolutionary concept, and it's really taken off because of our ability to engage in high-speed computing and our ability to run queries that produce a data set or a view. And once we're through looking at it, or printing it, or sending it somewhere else, or analyzing, say, exporting it to Excel or a spreadsheet application for greater analysis. When we save the query, all we do is we save the query. Now we can run queries to alter the table, update it, etc. We've talked about that using forms. Okay. But when we start to harvest them and we use these queries, we just simply save the code. And that's the beauty of this, is we can take that table and we can have it being updated, okay, as we're running code from it. But we can store the table in a way that saves an enormous amount of money and space. Unstructured data is another one of these things we talk about. So you hear people talk about big data. Unstructured data is data that just doesn't readily fit into a table. Tweets, comments on Facebook, things that are the number of likes for a given Facebook post or tweets, on and on and on. Then we have all of this information, we have all this data that's being produced by devices where we've embedded a chip that transmits data out to a server. All kinds of imaginable products. That doesn't count all the sensors that we have. Out in the middle of the oceans of the earth, we've placed sensors to help us try to figure out, what's happening with climate change. We have them out there to try to do some prediction on weather, to just monitor conditions. So I just can't emphasize enough to you how important this is. Now, if you attended the business forum yesterday morning, I hope you listened very carefully to what those three young men were saying. They were telling you spreadsheet skills are exceptionally important, but you need more than simply that. Now, I wanted to stand up and say you're exactly right, and what you're doing and you're experiencing is you're now seeing the use of databases married to those spreadsheets, those hybrid products we've talked about. But you take it from them. These are people who are out there working. They're not that much older than all of you. And what did they tell you? Get all of the technology you can get. Now, if that won't convince you how important this course is, or any of these courses we give you in the BISS courses, I'm at a loss. Let's continue on now. And so they show us the best approach is to join two tables at a time. And look over at page 474. Notice what's going on. We have two tables, then we get an A-B table. Then we add C, then we add D, and we get a result table. As I've said before, we leverage large numbers by using joins. So we're going to look at the inner join of two tables using a one-to-one relationship. And so we're going to go over to the code for chapter 13. And this will be 13.3. Now, before I put this into my SQL, into my Access file here, and I run the code, I want you to notice something, okay? Watch what's going on. You have a select statement. And notice this says a.fruit, a.f underscore number, B.C underscore number, B.color from section 1303 fruits A, section 1303 colors B, where A.F underscore number equals B.C underscore number. We have used, we've identified, well, we have created table aliases. Now, the scripting that we do here, okay, is we're using the table, then a daughter, and then the name of then table A, and then what we want from that. But here's the key part right here. This is where we've pulled data. We've identified the two tables we're getting data from, and this is where we have the inner join. And then we order it. So we're going to run 13.3. Okay. Now these, I understand, seem simplistic. If I were to tell you, and we'll click create, inquiry design. But if I were to tell you that the amount of data we can collect on the table, there really is no limit, but we do, as we've talked about before, using lookup tables, tables of constants, fact tables, and we looked at the data, we looked at Northwind traders. But this ability to join tables by using a foreign key that's embedded in another table as this creation of a foreign key, where we can link the two tables up. Now, in this case, we're using an inner join, and the authors show us over there how we have the beginning table, then the relationship, then the beginning table too, and then we get the result table. And you can see that. That's 13.3. So we're going to call this 13.3 and save it. Now, these are simplistic examples. I understand that. We could have been dealing with two tables that have 25,000 records, that have 50,000 or 100,000 records, 1,000,000 records, or a combination of tables in a data mart that have that much. So, and I've talked a lot about, okay, a disciplined approach to running these queries. And we see that. Now, here we use the table aliases. Okay. And let's go back to the code here for a moment. Take a look at it. By using the A dot, B dot, what we basically did, we had two tables we were working with, but we used the table alias, and the authors talk about that over here on page 481. And it's a way for us to alternatively basically assign an alias, and thus really we can be essentially working from two. We can have the same table, but now with an alias, we've got twice as much table we can work with. The authors do a fairly good job of talking about that. And of course, we see the join here. Okay? So that's 13.3. And here we're talking about a one-to-one relationship. Next, we have a one-to-many relationship. They show us that over in 13.4. So let's run 13.4. Okay? Now, in this case, we're assuming a one-to-many relationship. An example would be a customer. A customer, hopefully, will make an infinite number of purchases from us. That's only one customer who makes multiple purchases. So that's what we call a one-to-many relationship. You're going to find this when you're dealing with customers. You're going to find this when we deal with, say, the product is the one, and how many times is that product sold or in transactions, or how many component parts does it have. It's not really hard to understand. It's just something you just kind of look at and say, okay, but you understand this is the way we leverage things. So we're going to copy that code and we'll click create. And we'll go into the query design. Okay. And I'm going to run the query. And this will be 13.4. And they show us over on page 483 the code, the task, okay, and then the two beginning tables and the result table. Some examples of in fact, table 13.4, pardon me, is a many to one relationship. I was talking about one to many. It's many to one. I apologize. And here we've done the inner join, and we have a many to one relationship. Some other examples would be like city to counties, users to Facebook, counties in a state, states in a nation, clients to a consulting firm, a many to one relationship. Apologize about that. Now, over on page 45, we talk about a one to many relationship. And so let's grab that code and take a look at it. I'll go through the create, query design, close it off, SQL, and we'll run it. Now, we're going to save this as 13.5. Okay. Now, Here in the one-to-many, as the authors mentioned, the roles in the tables are reversed. And some suggestions of one-to-many would be a mother to children, an actor to the roles they portray, the department to the number of employees in that, customer, and the number of transactions they have. And Facebook, a user to friends of that Facebook user. So the one-to-many relationship. Okay. So we looked at an inner join, and now, well, we're still looking at inner joins, but in terms of just a straight match versus we're looking at the many-to-one relationship, and then we look at the one-to-many. And notice again, we use that pattern. You have your textbook. We use the table aliases. And they show you over there in at page 486, the two beginning tables, and we end up with the result table. And the author also provides that shading so you can see those records and how they're extracted out. Now, there's also a many-to-many relationship, and we're going to see that here in 13.6. Okay. I'm going to run that. Okay. And over on page 487, they show us the code. And we use a many-to-many relationship between the table. Some good examples are going to be authors to books, orders to products, cars to VINs. We're getting combinations, mixtures. We're getting combinations based upon the join. And notice that we have over on page 48, you can see the beginning tables for fruits and for colors. And then we get the result table. Of all of the tables that are the most important or the most powerful is when we run the many-to-many relationships. Now, if you take a look at this, we have the two tables, and we have the fruits and the colors table. And we have some fruits that have different fruits, but they have the same number. Then we have a colors table. Okay? You can see that because we have that dimension table of constants, colors, and we have this other table that's built from, that has these different fruits with their numbers, we get a result set that's bigger than the two tables because we're using a many-to-many relationship. And you can see that there. if you look at each of those two tables, at the top, the beginning tables, there's 1, 2, 3, 4, 5, 6 records in each table. Look what happens when we get the results set down here. That result table in the middle of page 48, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 records that are pulled with 4 result sets. These help us look for patterns, for similarities. Now, the authors show us in 13.7 joins that we run where the unmatched rows are dropped. Okay? And let's take a look at that. And this is 13.7, and it's over on page 490. And we've got the fruit, the number, color, and then we identify the two tables. And we order it by the fruit now. The authors show us there at the bottom of page 490 that the beginning tables, okay, those rows don't have a matching row in the other table, so they're just dropped from the result. We can also do it with null values in the matching columns. And we've got this 13.7, so let's go ahead and run it. Oh yeah, okay, we have. Just give us 13.6. Down here for just a second. And here we have the color table. Yeah, that's 7. Now let's look at 13.8. The narrative for it starts over, the code for it's over on page 491. And if we have a null in the column, we want to drop it. Okay. This keeps us from having to have a bunch of, we get rid of the nulls essentially. I will say this is 13.8. Okay. And notice there in 13.8, the code on page 491, we're selecting the fruit and the number from the table A. We're getting the number and the color from table B. And then we identify the table aliases. And then where the number equals the number in A, the F number equals the color number. Now they show us the beginning tables over on page 492. And they show us that we have a table there. The kiwi, the 1308 fruits table has a kiwi, but there's null. There's nothing in the column for the fruit number. And then if you look over here, if you look at the table on the right side, you're going to see that brown doesn't have a number. So you don't see the kiwi in there because we dropped that when the rows don't match, we drop them. Here's the way that we get rid of nulls. And we do that straight match. Now the authors walk us through 5 over in 493. There are 5 ways to write SQL for an inner join. Okay. And over on page 494, they show us variations. They say the first variation, number 1, is the best solution. And then over on page 495, they tell you the code that's not recommended, that it's confusing to people. Now, over on page 493, the author is going to explain to you each of those variations and what's going on there. Now, if you look at there at variation number 2, you're going to see something a little different. Notice that code there, A dot asterisk comma, B dot asterisk from, and then we identify the tables. You say, well, okay, the asterisk lets us pull everything from the table. So the column alias dot, the asterisk says, pull everything from the table alias, pull everything from that table. And so we do that for table A and for table B. That's what the dot is. I mean, the asterisk is after the dot. We identify the 2 tables and we match them up where the F number equals the color number, the fruit number equals the color number, and then we order by fruit. He says there's some variations as well. He likes number 1 the best, number 2, he has them in his order. So it's a useful page there and some information because it shows us some ways that we can write the inner join using and that's 13.8. Now, I don't think we really need to, I think you can see for yourself the results that you'll get. And remember now, the ordering, how we order things. and what we ordered has tons and tons of consequences. Um, 1310, the authors tell us about a joint that uses 2 or more matching columns. And you can see there, we match up the, and I'll just go ahead and get this up and highlight it here. Here we are. And we match on 2 or more, we use 2 or more matching columns. And you'll see this as you come down. Once we do the select statement, okay, then we identify the 2 table aliases. And then we use the where statement. And we use a Boolean equivalent for the fruit number 1 and the color number 1 and the fruit number 2 in table 2, the fruit number 2 and then the color number 2. Now, for 1310, at the very bottom of the page, it's easy to get confused with this. You'll want to take a look at it real carefully. The beginning table for fruits and for colors. And then there's our results set. Now, you'll notice that 1310, if you look at the bottom of page 496, excuse me, you're going to see that both of those tables have 5 records. And when we run 1310, we're going to get 5 new records with everything ordered out where they match. So let's go ahead and copy this. And we'll run it. And this, of course, is going to be, I'll go to SQL. And we'll run it. And this is going to be 1310. Okay. And so if you look over at the top of page 497, you see the result table. You're going to see that we have that and we had ordered them by fruit. And because, and they give us some notes. All the columns are listed from both tables. The join condition is written using the where clause. And then the author says there in point number 3, the order by clause is not really part of the join, but it's included here to make the result table easier to read. And so we know it's ordered by fruit. And we know that in any database application, the default is ascending. And you'll notice here we've got these in alphabetical order. And we see where they match up. 1310, you can take a look at it. And this is where we create a join using the between function. You'll see that at the top of page 498. Now we're really starting to get the leverage the power of these, because when we use the between clause, now we start to say, okay, I'm filtering records. So I'm not only grabbing records and ordering them, I'm now filtering them. Okay, so I'm taking now. I'm eliminating stuff that's not within a particular set of parameters within a certain date, and you can see that where the test score is between the beginning score and the ending score, and we see their beginning tables, and then we get the result. And we ordered it by student name, and notice that the student names are in order. They're alphabetized. 1312 is another one of those. We use the greater than condition. And they walk us through that over on the bottom page 499 and 500. They show us the two tables, then the result table. Now, over in 501, we do a join using a row function. And you say, where's the row function? Well, if you look there in 1313 in the code, you're going to see where we have a table A fruit number plus a table B color number. And we add them. Now you see and we order them by fruit. And we pull those where the 2 equals 6. So we can say, give me a list of all of my clients who have bought $100,000 worth of $100,000 worth of merchandise in several transactions. Over in 1314, they show us using the from clause. And then it shows us some newer syntax where you literally put in inner join. And you can see here's the result table versus the solution table. We talk about the application of joins. They talk about a lookup table. For example, here they give us this departmental table. If you took BISS 1123 with me, I showed you where we had some tables of constants, and we went into the field properties and ran that little query so that we could get a drop-down menu. So that's basically the same thing that's going on here. Then they show us over in 1316 where we have two functions. Notice, department code, we have an equivalency function, then we have less than. And they walk us through those steps to get the result table. (13.7) is one where we use a summarization technique. If you look there on page 511, you'll see in that code it says count asterisk. So we're going to count all of the lunches. Now the authors end up talking about finding the primary key in the Oracle data dictionary. And Access, you just go in to the GUI. We talked about that before. Frankly, this part is probably wasted on you as an end user or decision maker because the primary key and all that will have been already determined for you. Now over on page 514, the authors really show you how powerful this technique is. Look at all of the statements of equivalency. We even include a literal, that's that SHP for shipping. And we order it by employee ID, and then we also order it by lunch day. And notice what we've got. Now, all of that is drawn from those two tables. And you can see all the records. Now, at this point, we're starting to see the kind of result tables. I mean, the table at the bottom, the result table at the bottom, page 514, frankly, it's small. It's a tiny example. You may have 50,000 records of output. And so you'll be able to look and say, okay, what all did Woods buy and when and in what quantity? Dan Smith, Fred Campbell. Okay. This is the point where I probably will use some type of spreadsheet or analytical engine. I would take this and I'd export it into Excel. And then I would probably, so I get a visual of the data, I'd probably put it into Excel using a pivot table. I might just export the table and then maybe use a sum if or a variable lookup function. I could even do a chart for all matter. If I really want to do something simple, I could use conditional formatting to move me on just this list of records to try to find some meaning. I'll give you a quick example. We've got Martha Woods, Dan Smith, and Fred Campbell listed here. We got three people. Well, which one of them buys the most stuff? Which one of them buys the most fresh salads? As you can see, this is the point where I want to move this into something that can give me some totals and some numerics, some data, mathematical operations that are just a little bit easier for me to handle. Compute averages, means, etc. Well, folks, I took it pretty slow. There's a lot in chapter 3, a tremendous amount of insight. And this is where I hope you start to see the power of this technology and what it can do, and how applicable it is to just about any kind of enterprise. I want to say one thing and finally close it off. If you attended the business forum Friday morning, you'll notice, I think it's at least one of them, I think it was Brad Johnson. can't remember which one of them said, employers want you to think like an owner. When you've heard me in classes say, my goal is for you to become an enterprise thinker, that's kind of a fancy way to say what those gentlemen said. Think like an owner. You heard them talking about and stapling stuff together and putting it into a folder to be mailed. I want to do that the best I can. People who have that type of work ethic, who have that sense of ownership, are folks who are going to go places. Now, in the world of accounting, as you heard, there's a pecking order of types of firms. In the world of accounting, you go through a series of stages like you do in a law firm or an architectural firm, where eventually you become a partner. And so at that point, you're one of the owners. You're no longer just an employee. So that's what I want you to do is to be an enterprise thinker. Think like an owner. Think how powerful this technology is for us. What we can store in tables. And now, before we have it stored in tables, we have to go out and get the data and clean it up. And there are a lot of different ways to do that. And often you'll find that, I think in this class, maybe in the business problem analysis class, I have you go out and get some data and clean it up. I know you for sure you do that in business problem analysis. Well, that's pretty much it. I think I'm going to stop and call this a class session. And we're going to really start to see the ground floor of how incredibly useful this technology is and what it can do for us. And how it can get we can get deeper sets of insight. And now we're building that analytical cube that I've talked about and shown so many times. Okay, well, thank you. God bless you. And I'll see you next week.